Jan, thanks very much for sitting down with me. Much appreciated. We're here at the meeting of the Upov Working Group for Biochemical and Molecular Techniques, the BMT, and you're here not as ILVO,
No.
but representing Ciopora.
Yeah. So Ciopora is International Association of Plant Breeders, but we focus only on asexually reproduced plants.
Mm-hmm.
So it's merely about ornamentals and fruits.
Mm-hmm.
And different to the seed sector, it's a different scope of companies that we have. We have very small companies, almost single persons, almost hobby breeders that create varieties, up to companies like Syngenta that are large entities, or Dumen Orange in the Netherlands that embody many companies and many crops. So also there is a huge diversity in how far people or companies are engaged in using BMT techniques, like we call it, in the breeding work, and that makes a huge difference.
So they use these techniques in their breeding work?
It's especially in the larger species. If you look to ornamentals, let me separate the two things, because ornamentals is a little bit different from fruits.
Okay.
In ornamentals, it's really only the big ones that use it, and they do it for the conventional, the usual things, check of crosses. Sometimes they use it also for introgression of traits. And in fruits, it's a little bit different, because in fruits you still have, like in apples, you have still a lot of universities and research institutes that are involved in breeding. So there, the link with science is often closer. And it's also fruits, they have a long lifespan. It's not so easy there to evaluate certain traits, so they rely more often on markers, even for screening of gene pools and these kind of things. But the trend that we see is also in ornamentals that because of the activities of the larger ones, that like Dumen Orange, they really have taken into their business strategy, when they have a marker that is linked to a certain disease resistance, that they go for a patent.
Okay.
And that makes it, they do it. Of course, they can use it internally for introgression of the trait and seeing in their varieties if it's available or not. But then you don't need to patent it. Then you can also say, keep silent and make use of it and store it as a company secret. Sure. But the fact that they patent it, it's merely done by the reason that they want to enlarge their scope of protection. We all know and we benefit all of the breeder's exemption. So companies can make use of other companies' new varieties and breed from it. But if you put a patent on a certain marker linked to a certain gene, you can enlarge the scope a little bit, because your group of varieties can be on that trait be discriminated from the remaining part. But that creates in the competitor companies a pressure to see how am I not by accident using the same genetic resources, and so on and so on. So they really come then to the institute, to ILVO, to ask, like for chrysanthemum or roses, the thing that has been patented for powdery mildew or Japanese rust, isn't that resource not available in the breeding material I'm using? So step by step, the whole thing is moving in that direction.
Interesting. I never thought of that specific aspect. But it's not just the companies that are using these techniques.
No.
It's also the US examination offices. In your view, should these offices be using more of such tools?
Ciopora and IRBA, the Rose Breeders Association, that is a crop section of our association, we are now engaged together with Hangzhou to develop a marker set for DOS purposes in roses. So actually, all the cut rose breeders have agreed with Hangzhou that they have signed MTAs, and so they send in material, and they keep an eye on the progress of that work. So, and they really are aware and even more engaged and aware that they might use, they are really interested to use these techniques, because not so much on management of reference collections and so on, because for them, the first thing to do is to compare on a phenotypical basis. That's clear.
Mm-hmm.
They want their rows to be seen in the greenhouse or in the field next to a rose that is very comparable to it. But if you look to roses, for example, there are 30,000 possible varieties in roses described everywhere in the world. So it's impossible that you cover all these things. So it's very good that we could have a database on the most common ones, not to see which one should be put in the field, that we can do based on the phenotype, but that we have a backup system just to check that we didn't miss very similar ones based on the genetic profile. And that's a bit the philosophy that is now behind it. Let's do the normal phenotypical testing, but check in the database if we don't miss possible candidates that we overlooked in the first place. And I think it's for people in vegetatively propagated crops, they have other concerns than people in the seed business. We do really have to rely on a strong PBR system because it's so easily to propagate our material. So somebody skilled in the art, he can take a bud or a cutting or whatever and start his own business based on that. And if you don't have strong PBR, you're lost. And there is a real trend to go to a system that at the moment that the title is granted, that we also get a kind of plant passport. That's really what we're after, not only with a description of the traits, but also showing, if you have an agreed market technology, a profile. That we can say, okay, we have a passport, we can take it throughout the whole chain. So we can look to infringement, we can look to EDV with the same technology. And that it's much stronger for our breeders.
So that's a whole lot of purposes for the offices to
yeah, but the office should not deal with that. The breeders can deal with that later, but it's always good that you use the same standard, and that when you have a passport available already from the beginning, like we do now with the morphological or phenotypical description, that we have a backup system that we can, but because what happens now, if there is an infringement, people send these materials, for instance, to Hangzhou, to our lab, to have samples to be compared. But if we already agreed on beforehand which tools we can apply, it's much more easy.
Yeah, sure. I know that the companies have been using these tools and techniques for quite a while now.
Yeah.
The US examination offices a bit more recently.
Yeah.
Is there a trend visible among the offices?
Yeah, because there are, at least for the major ornamental crops and fruits, there are not so many examination offices that are accredited to do it. So if one takes the lead, like in roses, Noctemba will do it, Bundessortenamt will follow, and they can use the same technology. So I think if we can do it together, and a breeders association that is and a dedicated office, we can move forward. Yes.
Yeah. So when we talk about these examination offices, we're also seeing that some offices, you mentioned already several, are readily implementing these techniques. Others are more hesitant. Wait a little bit. Should we and can we bridge the gap?
Yeah, I think so. Yes, because it's often not too many examination officers that are responsible for a certain crop, and we are also very much in favor of harmonization between the offices. So if you're at the same, let's say, Upov 91 level, that offices can share their examination reports between countries and so on. That's what we are really also much in favor of, because ornamentals and fruits in a lesser way, but ornamentals for sure, it's a worldwide product. So if you create a cut rose, it will go to Kenya, to Colombia, Ecuador. So if you every time have to make the application in that different member state, it's a burden for the breeder. So we are very much in favor that when you have a title granted somewhere that other examination officers, if they want, they can take over. And in that way, we also think the use of molecular markers, it is not necessary that we build databases with thousands and thousands of markers. We can really focus on a set of markers that is optimized for making visible the diversity as good as possible that is available in the current set of varieties. So maybe in roses we think about 100 markers, SNP markers. With microsatellites it can be even less because you have this multi-allelic system. And then you can make a good estimate already. And if needed, if you run into a potential case of EDV and so on, you might enlarge the thing and take another additional set of markers that covers more, that covers certain traits or whatever you want. But that's something that the companies can deal with within themselves. So we don't need the examination office to do it. But of course, it should be very nice or easy if examination officers run in a potential case of ADV that they flash up a little light and say probably, but that's something there are no protocols for it. So it's, we discussed before about the ownership of DNA, material, information, that kind of thing has to be established first with the necessary MTAs before you can do things like that.
But I'm sure it can be easy. There's several hurdles to overcome. What would you say are the main challenges implementing these tools?
Implementing the tools for the moment, it's for the major crops, they are available, but we are dealing with a huge variety of species. And that at the moment, we are a little bit in lack. You can go to sequencing, but that's quite expensive. It's not that expensive anymore as in the past, but still it's quite laborious and a lot of interpretation is needed to do that. And it's not something that is finished within 1 week. You have to make libraries, send it to a provider, and then you have to analyze the data and so on. So in the past, also in our group, we used ILVO a lot. And that was easy because it's an easy, accessible technology that can be used in any conflict you have. You have whatever species coming in, you can compare two plants and have a decision, at least if it's identical or non-identical. And you might discuss if there are small differences, if it's an EDV or whatever, but that's the more complicated case. But AVLPs, they are error prone in a way, and some judges in the Netherlands, for instance, said, we are not so much in favor of that technology. So it should at least be microsatellites or SNPs. And if you come to me with whatever small flower that you picked up in South Africa and that you developed in a new ornamental, I don't have the techniques at hand. And that makes it a bit difficult at the moment. But I think in future, everything will become cheaper again, and technology will move forward. So that will be solved by itself, I hope. But that's, I think, at the moment, a major hurdle. But for well-established crops like rose, chrysanthemum, the major orchids and so on, tools are available. Huh?
So the developments are going very rapidly. Each year we're seeing new techniques becoming available. Speed is going up, costs are going down. Do you think, seeing all these developments, that over time all variety testing will go to molecular tools?
As an association, I have my personal view on it, but as an association, we are not in favor of it. Because at least Ciopora deals with two important issues at the moment. We have the EDV discussion that will, hopefully, the end of this month, have a new interpretation or a better interpretation, let's say. But the other thing is minimal distance. And with minimal distance, we mean the distance that you have between accepted or granted varieties. And we see that in certain species, for sure, that varieties tend to get closer and closer because, it's a double action. At the one side, there's the breeder of a new variety that thinks, yes, my variety is better because of high production or higher quality or less use of pesticides or whatever. So it must be different from my competitor's one, but maybe your morphology is not fit, the morphology of the phenotypical analysis is not fitting to it. So you will bring in new evidence saying, yeah, but look here and there, and then it looks different. But that, if it's about disease resistance or productivity, then it's not a problem. But often we have a kind of plagiarism, that people want to bring in varieties into the scope of protection of the market leader just to take a share. And then that's not fair in our thinking. So therefore we say, okay, let's stick for the granting of the title. Let's, in the first place, look to innovative varieties that bring something new. And small things like flower color, they can be very innovative in a certain species. So please, at that level, let's make use of phenotypical data. But of course, we don't, then we come to the other end. EDVs can be very innovative and very different from an initial variety. We don't want to block them. So we're a little bit, the thoughts have changed over discussing. Now, if you're the owner of an initial variety, you can really block the finder or developer of an EDV. So we are more in the view that there should be a possibility to get a license for the finder of the EDV at reasonable conditions. That we can say, okay, we make a share 40, 60, 30, 70, whatever, but that's at reasonable conditions, and that we don't block you. Then innovation will not stop. And there is nothing wrong with a mutant in flower color that turns from red to pink or to white or with stripes. That's an innovation. That's important. That should come to the grower and to the market in the end. But if it's only a little bit like sometimes you have seen here the Apple case and the Gaia, where they have all these apple color mutants, skin. I'm not, and Ciopora is not in favor of what the project is doing, use of epigenetic markers where you use RNA profiles to discriminate a tiny, tiny little difference in the color of a stripe on an apple that tastes the same. And this is a bit too far. This is what we don't want, I think. So I was not so much in favor of that Immodus project. It was not supported by Ciopora, but anyway, they got the grant. Scientifically, it's a very nice project because if you can discover traits that are behind this kind of variations, maybe you can make an innovative variety by CRISPR-Cas and new breeding techniques. Also there, we are not against it. We want to make use of it, but not for tiny differences.
Makes absolute sense to me.
Yeah.
Thank you very much, Jan.
Dank u, Marcel.